Howdy there, once again, YouTube. My name is Ben Ferriolo, and I study seismic data for volcanic and tectonic hazard areas. I am an amateur seismologist and have already learned a lot. However, know that I still have a lot to learn, and I've barely scratched the surface. If you haven't already, please bookmark my website. A link is below, my email address in the description box below of this video. It contains a crazy amount of information on how to find seismic data, how to analyze it, which programs to analyze it with, and much more. Trust me, it's much easier than you think. It even contains hundreds upon hundreds of seismic images and plots to many seismic events. In this video, we will discuss a few different things. First, I want to acknowledge the topic of daily harmonic tremor episodes at Yellowstone. They are not occurring. Sorry guys, I think I just pissed some of you off, but please, just hear me out first. Then I will quickly talk about the recent Steamboat Geyser eruptions, and the recent small swarm near Norris that actually occurred today, actually a little bit closer to Mary Lake. If this video is too long for you and you'd like to skip to a part of interest, please utilize the parts section in the description box below. First, let's talk about the rumor that harmonic tremor is occurring at Yellowstone virtually every day. I know I may piss some people off, but Yellowstone is still a major threat regardless of what I say. Harmonic tremor or not, Yellowstone still should be monitored greatly, guys. I also want you guys to keep in mind that harmonic tremor is just one of many different precursor warning signs at any volcano. And just like how all volcanoes are different, many harmonic tremor episodes are slightly different from one another from volcano to volcano, but they usually carry the same characteristics which we will look at now. Now here we are at the most recent page of isthistingon.org/Yellowstone. Now some people out there are saying harmonic tremor is happening a lot, or at least here and there at Yellowstone. This assumption is incorrect and derives from the inability to accurately and closely analyze the data streams from various stations around Yellowstone, which is much easier than people would like you to think. From what I have seen, harmonic or volcanic tremor episodes have not been spotted at Yellowstone since the 2008-2009 dike intrusion of Yellowstone Lake, maybe even a few in 2014 to 2015 when uplift reached its peak. However, those had low amplitudes and low frequencies as well. A harmonic tremor is a sustained release of seismic and infrasonic energy typically associated with the underground movement of magma, the venting of volcanic gases from magma, or both. It is a long-duration release of seismic energy with distinct spectral lines that often precedes or accompanies a volcanic eruption. And guys, that's not just from Wikipedia, that's what USGS says as well. And also, they can precede volcanic eruptions by months to even possibly years. So, now let's take a look at some of the examples of harmonic tremor episodes. First, we will quickly look at some examples posted by other people, and then we will look at my own examples from two select volcanoes, well known for harmonic or volcanic tremor sequences. Mount Veniaminoff in Alaska, and Mount Etna in Italy. But first, let's look at those other people's examples. Now, here are some seismogram and spectrogram plots of harmonic tremor episodes. Now, A, right here, is a seismogram of a harmonic tremor episode on December 15th through 16th, 2000. I believe at Popocatépetl in Mexico. I believe that's the volcano they are researching. Again, this is not generated by myself. This is from ResearchGate. And so we see the seismogram of the harmonic tremor right here. Can't really see it well because they have it on a small image, which I don't like. But you can see the spectrogram right here. And you can see 15, 10, 5. Those are the hertz ranges. Notice the dominant low frequencies mainly staying below 10 hertz, but the strongest frequencies remaining below 5 hertz. This is an exceptionally strong harmonic tremor episode, guys. C and D, these are spasmodic tremors, and down here it looks like there is a rapid-fire swarm that they detail as well. But again, there is another example of harmonic tremor. Harmonic tremor doesn't always look like this with these lines right here. Sometimes they do, sometimes they don't. It depends on the process that is taking place and whether or not it's going to lead to an eruption. So let's move on to a different one. Now, here are spectrograms of a different type of harmonic tremor. This type of harmonic tremor is what I like to call a pre-eruption harmonic tremor, also called upwards gliding harmonic tremor. It seems to be more of a rare type of harmonic tremor. If you're looking for precursor signs a few months, weeks, or maybe even a year or two before an eruption, then you probably won't see this. See this right here? That is an eruption, an explosion. Notice how it was leading up to the event, and then went upwards, the frequencies rose, and then stopped, and then the eruption happened. This type of upwards gliding harmonic tremor is usually just right. I'm talking maybe minutes, maybe even a maximum of a few hours, but usually just minutes right before an eruption. So that usually is not what we have to look out for. We have to look out for the precursor harmonic tremor, which has dominant low frequencies and sometimes usually lower amplitudes as well, and can last hours, days, even months. And real quick, here's an example of a very strange type of harmonic tremor caused by an iceberg. Yeah, apparently it can be caused by icebergs as well, but look at the frequency range. Look at this. Do you see this? Frequency hertz, 100, 200, 400. Yeah, definitely a much different, many more different characteristics than any type of volcanic or harmonic tremor episode. This you will never see. I mean, this is way too high. Frequencies are way too high. Definitely an iceberg harmonic tremor. Very interesting. If that is true, that is what caused this. And last but certainly not least, we have a spectrogram. Kind of an old-fashioned looking spectrogram, and they're both squished. These are both really squished. Too much time period, guys. Way too long. But anyways, you can see this is from an underwater volcano, I believe, if I'm correct. Again, frequencies are very high, guys. Look, the dominant frequencies of this event go up to 20 hertz. That is very weird. I am not dealing with that type of harmonic tremor today. I'm mainly dealing with the precursor long period type of harmonic tremor, which usually has dominant frequencies below 5 hertz, with long-lasting codas, guys, and with near-perfect waveform oscillations, sometimes going from harmonic tremor to volcanic tremor, to harmonic tremor to volcanic tremor. It can go back and forth sometimes, just like how we see at Veniaminoff and Mount Etna that we will see in just a second. So we saw two clear characteristics of simple harmonic tremor, and some other weird ones. It is much more than, whoopsie. There is one I forgot to show, which is this one right here. Now, it says these are marked. T1 is tremor with repetitive pulses. Not really talking about harmonic tremor, but tremor with repetitive pulses. Could be volcanic in nature. T2 is spasmodic tremor, which has mid-range frequencies. Notice how it's going up to about 10 hertz. We see a maximum spectrogram frequency range of about 25 hertz, which is usually the norm. And let's go down. T3, actual harmonic tremor. Here's an actual harmonic tremor episode. Notice dominant frequencies below 5 hertz, with barely any weaker frequencies going beyond that. I mean, some very, very, very weak frequencies do go up to 10 hertz, but the large majority of the event stays beneath 5 hertz. And this one was strong. It had a strong amplitude too, guys. I don't know where this was taken from, but it was very strong. And then regional earthquakes is this right here, which is a semi-distant earthquake. COL, which is this right here, is a collapse. LAH, which is right here, is a lahar flow. And down here we have an explosion, possibly a volcanic explosion. Here we have a long period event, which is a low frequency earthquake. Again, notice the dominant frequency range of the low frequency earthquake does look somewhat similar to the harmonic tremor. Notice that? That's because the processes of low frequency earthquakes and low frequency harmonic tremor are very similar. And then the last one, we have a VT, a normal volcano-tectonic earthquake, which seems on here to be going up to 15 hertz, but usually we should see it going up a little bit higher than that. So harmonic tremor is much more long-lasting than an earthquake. It always carries, well usually, dominant low frequencies if we're talking about the precursor type, and sometimes carries low amplitudes as well, meaning it carries low strength. So why are people so insistent on the fact that these are occurring at Yellowstone? If harmonic tremor were first to appear on one station at Yellowstone, it would surely appear on a few other stations as well, right? Also, in regards to them occurring at Yellowstone, it is highly likely any harmonic tremor episode will occur alongside an earthquake swarm. I highly doubt any harmonic tremor episode will just happen by itself and then go away without any earthquakes. Since a lot of the area underground is blocked, obviously with rock, just like it is elsewhere in the world, in order for magma to reach the surface for an eruption, it must first travel to the surface, right? Well, since it is blocked down there, like any other volcano or underground area, the magma intrusion event will 99% of the time create an earthquake swarm. No joke, guys, I'm serious. Magma is not peaceful and should never be expected to be peaceful. I mean, just think about the power of magma for a second, guys. Just think about it. It is basically lava, but also contains many gas bubbles as well, which makes it extremely volatile. Plus, it is extremely hot and very vigorous. Regardless, keep in mind magma intrusion always carries with it an earthquake swarm, as the rock breaks and fails, allowing the magma to push upwards. Here we are quickly about to look at the seismic signatures created by the harmonic and volcanic tremor episodes at the Veniaminoff volcano in Alaska. I am actually somewhat good at spotting harmonic and volcanic tremor now. You know how? I have taken well-known episodes, studied them, and applied the known characteristics to daily events. In other words, I taught myself and I practiced a lot based on what the professionals have already confirmed for other volcanoes. Now at Veniaminoff, they state the harmonic and volcanic tremor episodes go on and off, switching between harmonic to volcanic, from harmonic to volcanic, meaning sometimes it is harmonic tremor, and other times it is volcanic tremor. Well, the difference is mainly in that the waveform spacings. Harmonic tremor usually contains near perfect waveform spacings. Volcanic tremor can look similar, but does not really carry the same near perfect waveform oscillations. So volcanic tremor, still being caused by magma, is different from harmonic tremor, but can look very similar, and both could be caused by the same exact thing. Oh, and another thing, you're going to have a really hard time understanding any type of seismic process just by using the helicorder charts, these blue charts that you see here, and the UNAVCO spectrograms. The spectrograms put out by UNAVCO show frequency vertically, as labeled here. Notice how it says frequency, which means anything vertical you see right here is frequency. For example, right here would be a lower frequency than right here. Yeah, you know what I'm saying? And time period is recorded horizontally, as you can see right here, and the color range you see is power. This is just like any other spectrogram out there. It cannot show depth, otherwise the label on the left would say kilometers or miles, or something like that. It does not show gas, otherwise the power would not be shown. Plus, these spectrograms are generated from different channels within the seismic stations themselves, and I do not believe UNAVCO themselves actually have gas monitoring instruments in Yellowstone. I may be wrong about that, but we do know the spectrograms are not coming from those. Also, look at this. See how this frequency says, notice how it says a small m, not a big M with megahertz, because megahertz would have a big M. That's a small m with hertz. Notice that? That means millihertz. And notice how it says 500 right here? 500 millihertz is still 0.5 hertz. So that is way too low to even see harmonic tremor, guys. The lowest frequency ever seen for harmonic tremor was around 0.5 hertz, which is rare, but almost always stays around the 1 hertz mark, going down to maybe 0.7, maybe going all the way up to 5 hertz, but around the 1 hertz mark. Usually never going below 0.5. Sadly, that means you will most likely never, ever be able to see them on these spectrograms. Also, these spectrograms are basically useless, since any type of activity, even actual earthquakes, would be way too squished to see. Now, why would I say that? Because these spectrograms have a time range of 24 hours, which is way too long in such a small image. Way too long, guys. This is why I just like to generate my own customizable spectrograms in the seismic program Swarm, because you could customize them any way you want in Swarm. Now remember, if this was 24 minutes, then it wouldn't be as bad, but a whole day, 24 hours in one image, I mean, a magnitude 4 earthquake would probably look like a tiny little spike. Little tiny spike because it's so squished, right? The more data you squish into an image, the smaller the events look. Okay guys, sorry for getting off topic, excuse me. Now let's look at the characteristics of harmonic and volcanic tremor episodes at Mount Veniaminoff in Alaska during heightened eruptive activity. And we have station VNSS in the AV network, which is one of the closest stations to Mount Veniaminoff, pretty much right inside the crater, I believe. Now let's see, we have persistent rescale off, 95, okay, we're good on that. Let's use the spectrogram first. Notice, and again, this is already confirmed, constant low frequency background tremor. The professionals have already admitted that in many of their reports for Veniaminoff from the Alaska Volcano Observatory. You don't have to take my word for it. Just go to volcanoes.usgs.gov. Go to their updates, or go to the Alaska Volcano Observatory, click on Mount Veniaminoff, and look at their daily and monthly updates. And look at this. This is harmonic and volcanic tremor episodes going off and on, off and on, off and on. Notice that? And notice this? it stays below 5 Hz. But remember how the spectrograms from UNAVCO only show a maximum frequency of 0.5 Hz? Well, let's see the dominant frequencies of this event. It starts at 0.7 Hz. So let's say UNAVCO had those spectrograms for Veniaminov. You would not, I say again, you would not see much at all for these harmonic and volcanic tremor episodes because they start at 0.7 Hz, but the maximum frequency range of the spectrograms from UNAVCO are 0.5. Someday I hope they change it and give you the ability to change the spectrograms any way you want. I don't know. That would be nice. But again, dominant frequencies of these harmonic volcanic tremor episodes, look at the spectra. Notice how it primarily stays around this location right here at about 1.7 Hertz, starting around 0.7 and ending at about 3. Now let's go forward. Notice how it stays pretty much. I don't know what happened there. Jeez, what the heck happened there? I have no idea what that was. Alright, keep going, keep going. Yeah, it still primarily stays between 1 Hertz and 2 Hertz, right? Primarily. And yeah, so check that out. Yep, see, dominant low frequencies, but not too low to where the UNAVCO spectrograms would see them. You would not see them on the UNAVCO spectrograms. Saying that once again, sorry if I'm repeating myself. Let's go back to the actual swarm spectrogram, which instead of 24 hours, it has what? Let's see, 11:41:25. 11, which has 1 minute. This is 1 minute, guys. This is what you need to study these events. Look, the farthest I can go out is like, for the spectrogram, is not even 24 hours. It's got to be probably, I'm going to say, 2 hours. That's it. That's the farthest I can go out. But I don't want any farther than that, otherwise the waveforms will get squished. And all of these are harmonic volcanic tremor episodes. Here's the spectrogram again, with dominant frequencies remaining below 5 Hz, with a few spikes here and there, which could signify some extra low frequency earthquakes. Again, let's zoom in and take a look at this. Alright, so notice this would be considered harmonic, almost near perfect waveform oscillations. Notice how you cannot judge that unless you use the seismic programs. Now, we going throughout the day. Let me go forward. I'm just going to show you. Off and on from volcanic tremor to harmonic tremor. I believe this is harmonic tremor right here, because the waveform spacings are nearly perfect. Keep going forward, going forward. Probably some low frequency earthquakes in the mix as well. Going up to 2,000 to 3,000 amplitude count. Some days it was stronger, but again, this was going on for months and months and months. I believe it's still going on at Mount Veniaminov, actually. Months and months and months, guys. Let's go right here. Yeah, this looks pretty cool. Look at this. Let me zoom out. Let's just take a look at this real quick. Again, dominant frequencies below 5 Hz. This is what to watch out for when you see this on multiple surrounding stations at Yellowstone. Below 5 Hz, but above 0.5 Hz. And just lasting a long time. That's when to worry, guys. That's when to worry. But if it's around like 50 amplitude count or 100, I really wouldn't worry about it because that's tiny, but still, you still should monitor it closely. So now you know what it looks like at Mount Veniaminov, volcanic and harmonic tremor. Again, dominant frequencies below 5 Hz. Okay, so now let's quickly look at the harmonic and volcanic tremor episodes shown recently at Mount Etna during its increased eruptive activity on December 2018. Here we are at station ESLN in the IV network, which is one of the closest stations to Mount Etna, actually on its southern slope, in between the base and the summit, I believe, just halfway down the mountain. So, we see pretty much the same spectral characteristics that we saw for the Mount Veniaminov harmonic tremor, except these frequencies are slightly lower, starting at about 0.55 Hz. So it is possible if you had the UNAVCO spectrograms, you would just barely start to see it on the top line, on the top of the bars or whatever. But still, going forward, we see it still remains in the same area. And notice, let's go to the waveforms. You can see this is more along the lines of volcanic tremor. Some of the waveform spacings are near perfect at some times, but although Mount Veniaminov had more harmonic tremor episodes than volcanic tremor, Mount Etna actually had more volcanic tremor episodes than harmonic tremor. But I want to show you something real quick. Let's log power back on. Let's turn on the spectrogram. Now this spectrogram may look different because the last one I showed had a maximum frequency range of 25 Hz. This one only has a maximum range of 10 hertz, so it's going to look just a little bit different. But again, below 5 hertz, right here is about 5 hertz. Notice how it looks very similar to the one at Mount Vinayaminoff. Notice that? Constant, 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 constant. Maybe not as strong as Mount Vinayaminoff, but constant, constant. Right here, we see increased activity leading up to the eruption, which was right here. You see this? This was the December 24th, was it, right? Or is it 25th? No, I think it was December 24th, 2018 is when that eruption happened. A new flank eruption that spewed ash all over Sicily, Italy, and other areas. But I want to show you it, though. It's very cool to look at, actually. Let's show you right about here when the eruption was reaching its peak. Let me zoom out. Let's see, reaching its peak at about 11:30, right? So let's go to 11:30 just real fast. Go to 11:30. Okay, here we go right here. Now, check this out. 1E5, that is 100,000 amplitude count. 1E5, again, is 100,000. Now, the only way you could ever see harmonic tremor episodes this strong, I mean, look at that. It is so strong, weaker frequencies go up to 10 hertz. I mean, you know, weaker frequencies of harmonic and volcanic tremor can go up to 10 hertz, maybe even 15 hertz. But that's usually during eruptions, though. That's usually you do not see that during precursor activity before, way before eruptions, which I'm more interested in precursor activity that lead up to eruptions, months or even years after the precursor activity is seen. But again, we have almost near perfect waveform spacings, but this is more in the lines of probably volcanic tremor. But this is eruption tremor, though. This tremor right here was caused by the eruption, an active eruption. Notice that? 1E5 is 100,000 amplitude count, which is pretty crazy, guys. Yeah, it was a pretty large eruption. It was good sized. Notice again the tremor with earthquakes among the mix. Tremor, again, dominant frequencies remaining below. Oh, that's about 2 hertz, isn't it? 5 hertz would be right here. It's actually remaining below about 3 hertz, so that's very interesting. Then they had some many major earthquakes throughout the day. And now let's just go forward just real quick. After all of these earthquakes, after all of them where the harmonic tremor and volcanic tremor increased once again, here we see the eruption has calmed, so have the earthquakes, but the tremor remains, going up to about 10,000. 10,000 amplitude count, which is pretty crazy. Dominant frequencies are shown, if you log power off, are actually shown. We got some dominant low frequencies at 0.58 and a little spike right here at 0.3, surprisingly. But I don't know if that's related to the harmonic tremor episodes or not. Could be, but still, mostly remains above 0.5 hertz. Usually doesn't go to 0.5 though. I'm going to say the majority of the time you see harmonic and volcanic tremor episodes, they stay above 0.5 hertz. Here we are on my website. Under the seismic events drop-down menu, click Steamboat 2019 to come to this page here. Now also, don't forget, I have Steamboat Geyser 2018, which shows the seismic plots and images to every single steamboat eruption of 2018. This picture here was taken by USGS on March 16th, just after its first eruption of 2018, after it reactivated. As of right now, the 6th eruption of 2019 is one of the smallest steamboat eruptions ever, since it reactivated in early 2018. And guys, I'm talking about last night's steamboat eruption, by the way. It is basically the same size as the 3rd eruption of 2019, which was the smallest one ever since the start of 2018. However, steamboat eruptions are continuing, and it will most likely erupt again 1 week from the most recent eruption if it decides to stay on schedule. Stay tuned for more. The 6th steamboat eruption of 2019, which is the 38th steamboat eruption since it reactivated in 2018, occurred at 8:07 UTC on February 16th, 2019, which is also 1:07 a.m. Mountain Time, the same date. You can see the plots right here. Again, it is one of the smallest steamboat eruptions ever since it reactivated in early 2018. I don't know what's going on, but I do think it is going to continue for quite a while. I don't know when it will end. We see right here. I have to update this heliquarter chart, by the way, guys, because I uploaded this like right after the steamboat eruption ended, so it still doesn't have a much data stream at the end, so I'll fix that in a bit. But here you can see the steamboat eruption looks quite small compared to other eruptions. Now here's the 5th eruption of 2019. There it is right there. Here's the 4th eruption of 2019. There it is right there with the teleseism from, I believe that was the 7.0 in Mexico, I believe. Here's the third eruption of 2019. And there it is right there. Here's the second eruption of 2019. And there it is right there. And last but certainly not least, we have the first eruption of 2019, which occurred on January 4th, 2019. Go down. I do not mean for it to say 2018. Wow. Really? Oh my goodness. Man, I really was holding on to 2018, guys. And you can see it right there. So, I do have some mistakes on this page, seeing that it has to be 2019, not 2018. So I'll fix that later. And I'm not very happy, guys. The boreholes are going down. Now, sometimes they do have an issue attaching to the University of Utah servers and this website here. Sometimes it looks like the charts are going offline when really the data streams are there, and I'm still able to analyze the data that doesn't show here. But the data actually is missing. They are really going down. I'm not happy. Because LKWY and Borehole 208 will be out now, which means that if any swarm occurs on the northern tip of Yellowstone Lake, we have to rely on the more distant stations, which I don't like, guys. I like to use the closest station possible to get the most accurate reading possible. But moving on, also, sometime after the Steamboat eruption, there was an earthquake swarm that you can kind of see right here. For the following data for the seismic program waves I'm about to show very quickly, I will use YNR, YML, YPM, and YFT. But real quick, here is YML, and you can see the swarm down here. You know, it really wasn't anything too crazy. After all, I've seen much wilder seismic events at Yellowstone, many of which are posted on my website, but then again, this still is another rapid-fire swarm, a minor one, but still, it happened. Here, I have the data stream of the 4 stations I just recently stated. YML, YNR, YFT, YPM. Note the P wave arrived first at YML, second on YNR, third on YFT, and fourth on YPM. Although it showed third on YFT, it seems to be a little closer to YNR, I do think this swarm occurred just barely to the east of the location of seismic station YML, so I don't know. Probably maybe a little bit to the south-southeast, I'm thinking, but very close to station YML. Here we are in the seismic program swarm. I have the data stream from seismic station YML at Yellowstone, which was the closest station to this swarm here. Let's take a look. Let's first use the spectrogram. Oh, whoops. There we go. Let's use the spectrogram first. Here is that weird background activity. Now, this may be some type of tremor activity. I doubt it, though, because the frequencies are just too specific. It's too monochromatic for these 3-pronged frequencies right there. You can see one frequency there, one there, and one there as well. A little too specific. Remember, we saw harmonic volcanic tremor episodes usually occur at this line right here and below, but still, you never know. See, it seems like we had 3 earthquakes right here, 3 very tiny microquakes right here, only going up to about 800 amplitude count at the max. And that was just before the swarm started. We have a few more earthquakes throughout there, and then here is the swarm in question. Another rapid-fire swarm, this time occurring near Mary Lake. Let me zoom in real quick. Going up to about 10,000 amplitude count. I'm going to guess probably this was, probably more like a 0.4. I'm going to say this was 0.4, and this was a 0.9. But let's move forward to the more interesting ones. 1, 2, 3, 4, 5. Looks like we have 5 right here, occurring in rapid succession again. This probably right here, let's see, that's about, I'm going to say that's a negative magnitude earthquake right there. This was more likely a 0.3. This one, however, I'm going to say this is probably along the lines of a 1.8 to 2.0. Maybe not a 2.0, but it's almost going to 30,000 amplitude count, guys. Almost 30,000. So I do think that was about a 2.0, I believe, depending on how far away it occurred from the station. And then we had a few more earthquakes. Here's this one right here. Going up to about 7 to 8,000 amplitude count. Gonna guess probably a 0.6 or 7, depending on how far away from the station it occurred. Going forward, we have 3 more. Altogether, in this very tiny swarm, we have 1, 2, 3, 4, 5, I'm just gonna say, and then 6, 7, Yeah, I'm going to say 7. 8, 9, 10, possibly 11, 12. Let's move forward. 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. So I'm going to say no more than 22 earthquakes in this swarm within approximately 10 minutes or so. 10 to 15 minutes. So it wasn't too crazy, guys. And by the way, this is not how, you know how on my pages on my website I do have estimated earthquake counts for a lot of the earthquake swarms and rapid fire swarms near West Thumb Lake at Yellowstone. This is not how I do the estimated earthquake count. So don't worry, guys. I don't just sloppily do it with the spectrogram. I look at the P wave arrivals on a few surrounding stations with the programmed waves, and I determine it that way, which is way more accurate than just saying, oh, here's one, here's one, here's one, here's one. I know I did that for this swarm, but you can obviously tell these were earthquakes. But still, I'm going to say probably no more than 20 to 22 earthquakes within about 10 to 15 minutes. So, nothing too major. Again, it happened near Mary Lake, and that's the end of this video. I forgot to do one more thing, though. I want to check the dominant frequencies of the largest event. So let's go to Spectra, log power off. We see dominant frequency starting actually at about 2 hertz, going all the way to 12 hertz. So it was not a low frequency earthquake, but you could tell it did have dominant lower frequencies below 10 hertz. So I'm going to say kind of mid-range frequencies, but it did have weaker frequencies going all the way up. So wasn't a low frequency earthquake by any count. But again, we had a swarm. Here we are back at the wonderful Old Faithful webcam, pointing towards Old Faithful within the Upper Geyser Basin. Actually, Old Faithful's kind of over here. This is Geyser Hill with a bunch of other geysers. I think Beehive is actually right there. Now, what is that? What is that bush right there? I've always wondered what type of bush that is. It's very weird. Almost looks like some type of cactus, but I don't know why a cactus would be growing there. I hope this video helped some of you understand what harmonic and volcanic tremor episodes look like. If you ever have problems, just take well-known harmonic volcanic tremor episodes and study their characteristics and keep them in mind for whenever you think you come across other harmonic or volcanic tremor episodes. Remember, harmonic tremor itself can look different just minutes before an eruption, but any real precursor harmonic tremor will likely carry near perfect waveform oscillations with frequencies anywhere between 0.5 Hz and 5 Hz. But remember, if you are only using online helicorders, also called webicorders, to look for harmonic tremor, then it won't work. You really need to add the seismic data to a seismic analysis program and be able to zoom in on the waveforms. Thank the God of heaven and earth that finding and analyzing seismic data in seismic analysis programs is actually pretty easy. My website is already dedicated in telling you how to do that. Just go to the link to my site in the description box below, right under my email address, and go to some pages within the How To drop-down menu. Steamboat Geyser also erupted for the 6th time of 2019, the 38th time since it reactivated in early 2018. There was also a minor swarm near the Norris and Mary Lake area, but it was not crazy. However, as stated in my recent monthly update, I am expecting Caldera-wide uplift to start again in the next year or two. We will just have to watch closely, and any major changes to Yellowstone or other volcanic hazard areas will be posted on my website and on my YouTube channel here, but most likely on my website first. So just monitor multiple pages on there, because I also have multiple blog areas and multiple pages I'm still adding stuff to, so just check it out. Please let me know what you thought, and God bless. Remember, the truth is considered hate or fear to those who hate or fear the truth. Ben Ferriolo, signing off.